Good afternoon, everyone. So recall that in the last class we discussed three questions of tutorial sheet 3, tutorial sheet 2. Now we will cover four more questions which are mainly based on expectation variance. So first question says that we have given x as a random variable. Values of x could be 16, 18 and 20 and corresponding probabilities are given. We need to compute expectation of x square and variance of x. So recall the formula for expectation x. It is summation x px or summation x fx. Expectation x square is summation x square p of x. And similarly, variance x can be defined as expectation x square minus expectation of x whole square. So now the computations are very easy. For example, for expectation x, it is 16 times 0.2 plus 18 times 0.5 plus 20 times 0.3. Similarly, you can compute expectation of x square. When both are computed, then variance x can easily be computed. The next part says that if a price of a freezer having capacity x is 70x minus 650, what is expected price? So expected price, they are asking the expectation of 70x minus 650, which is a function of x. So h of x is a function of x, which is 70x minus 650. So now recall that expectation of ax plus b is a times expectation x plus b, where a and b are constants. So it means expectation of h of x would be 70 times expectation x minus 650. Expectation x has already been computed, so by substituting the value we can easily. The next says that find the variance of the price paid by the next customer. Now variance of ax plus b is a square variance of x. So it means variance of 70x minus 650 is 70 square variance of x. So by substituting the value, it comes out to be 9604. The next part says that the actual capacity h of x is x minus 0.008x square. So find expectation. So again, expectation of x minus 0.008x square, which is function of x, is expectation of x minus 0.008 expectation of x square. So constant would always come out when we are finding the expectation, and in case of the variance it behaves a little bit different, but it comes from the formula that variance x is expectation x square minus expectation x whole square. So the answer comes out to be 15.54. The next question says that a small market copies order of certain magazine, let x is equal to demand for the magazine if all the mass function is given. Now it says that let owner actually pays $2 for each copy and it sells customer to $4. So it has a profit of $2 on each copy. If magazine left at the end of the week has no value, so what is better? Should he order 3 copies or should he order 4 copies? So whenever such question comes that order 3 copies or 4 copies, so you need to see that the average profit, and whenever average word comes, it is related to expectation. So it means that we need to compute the expectation when he ordered 3 copies and when he ordered 4 copies. So let h3x represents the function of x when he ordered 3 copies, and h4x represents when he ordered 4 copies. Now profit depends on the demand. So for example, when he ordered 3 copies, So it means that he spent $6, and in this case he spent $8. Now if x, depending on the values of x, you can compute h3x and h4x. So when there is a demand of one copy, it means from the customer he will get $4 and he spent $6. So there would be loss of -2, and here there would be loss of -4. So which is 4 minus 6. When there is a demand of 2 copies, so 2 times 4 minus 6, which is 2. And here 2 times 4 minus 8. This is 4 minus 8. So this is 0. When 3 copies are in demand, so it is 12 minus 6, which is 6. And it is 12 minus 8, which is 4. Now when 4 copies are in demand, but we actually have only 3 copies, so it means we can only give 3 copies, so therefore this remains 6 only. In this case we have actually 4 copies, so 16 minus 8, which is 8. Now in case of 5 also it remains 6 and it remains 8. In case of 6 it remains 6, it remains 8. Okay, now you can compute expectation of h3x and expectation of h4x, because probability are already given. So it is summation h3 small x and p of x. This is summation h4x and p of x. Once you try it, you will realize that this comes out to be 4.93 and this comes out to be 5.33. It means the average revenue when he orders 4 copies is larger than the revenue when he orders 3 copies, and that's why it's better to order 4 copies. The next question says that let x be the damage incurred in dollar in a certain type of accident. The possible values of x are 0, 1000, 5000 and 10,000, and probabilities are given. A particular company offers $500 deductible policy. It means that if you claim for 1000, they will give you 1000 minus 500. So whatever you claim, they always deduct $500. So let h of x be the function, and in that case when you claim $0, of course they cannot deduct $500, does not make any sense. But in case of 1000, they can deduct 500, they can deduct, and they can deduct. So this is your h of x, and probabilities were already given. So 0.8, 0.1, 0.08 and 0.0. Yes. Now if company wishes its expected profit to be $100, yes, then what premium should it charge? So for the profit to be $100, first you need to see that how much company has to pay on average accident, because there are only 4 cases. So average means you have to find the expectation of h of x, which is summation h of x and p of x, which comes out to be 600. Do this calculation by yourself. It means that on an average per accident they have to pay $600, and if they want a profit of 700, they want a profit of $100, so it means that they must charge $700, which ensures that they would have a profit of $100. So the premium should be $700. The last question, it says that a particular telephone number is used to receive both voice calls and fax messages. For fax messages, 25% of times fax messages, so fax message probability is 0.25 and voice call probability is 0.75. Incoming calls are 25, which is fixed. What is the probability that at most 6, exactly 6, at least 6, and so on involve a fax message? So one idea is that you can always compute these values. For example, if you are looking for x would be the random variable which talks about the calls involve a fax message. So if fax messages are 6, if you are looking for probability of x is equal to 6, it means out of 25 it is 6, and each 6 has the probability 0.25. It means the remaining one have the probability 0.75 raised to the power 90. Yes, so the idea is very simple, but if you do all this calculation it takes a lot of time. So what you need to understand is that it is binomial distribution. How it help if you know it is binomial distribution? If you know it, then in the book there is a table. From there you can directly see the values. You don't have to do all this calculation. This is the only benefit. So for the binomial distribution, the first question at most 6, you have to ask for cumulative distribution for 6. So for cumulative distribution you use capital B. So 6, n is 25 and probability is 0.25. And if you see the table, it is 0.561. Exactly 6 is binomial distribution with x is equal to 6, which is small b. 6, 25 and 0.25, it is 0.183, and so on can be computed. The next one asks that what is the expected number of the calls. So expected numbers means you are finding expectation x. So instead of doing all the calculation, you have to remember the formula. When it is binomial distribution, it is NP. So n is 25 and p is 0.25. Similarly, for the standard deviation, first you need the variance x, and its formula is NP1 minus p. And the standard deviation is root of variance x. The last part says that what is the probability that the number of calls involve a fax transmission exceed the expected number. Expected number means expectation by more than twice the, so probability of x greater than expectation x, which is 6.25 plus twice the standard deviation, which means you are looking for probability greater than 10.58. Now it's a discrete random variable, so this is same as probability of x or 1 minus x less than 10.58, which is 1 minus probability of x less than equal to 10, and this becomes again binomial CDF whose value can be seen from the table. So please do verify, the final answer must be 0.03. So that's all from this sheet. Thank you.